Hello, my name is Dr. Luke Bell. I'm lecturer in molecular horticulture at the University of Reading in the United Kingdom. This is a screencast of material originally made available for the module Principles of Horticulture and Crop Production from the years 2020 to 2025. Please note that some of the details may now be outdated.
So the learning outcomes are to describe the characteristics of Brussels sprout plants, explain the cultivation requirements of crops and that they are tolerant to sub-zero temperatures, understand the fertilization and irrigation requirements of the crop, and describe how Brussels sprouts are harvested and processed by machine. So just looking at the kind of botany and physiology of a Brussels sprout plant, they're quite unusual. So Brussels sprouts are of the species Brassicales and the Gemifera group. So they're completely separate to cabbages and broccoli and cauliflower. They're cold season crops which are frost tolerant and are biennial, but they're cultivated as annuals for the most part, but typically they can be overwintered, as we'll go on to look at. The leaves of the plants are quite thick and leathery, and this is what affords them some degree of protection to cold temperatures. The colour of the leaves can range anywhere from purple to green colours, and the roots are typically shallow rooting down to a depth of about 30 to 40 centimetres. So plants produce numerous lateral buds along a long unbranched stem. So this is thought to have arisen as a result of a mutation which was taken advantage of over the centuries to produce the modern types of Brussels sprout that we know today. The plants show a strong apical dominance, so they grow, the apical stem inhibits the lateral lateral leaf development, and plants can grow as tall as about 50 to 90 centimeters. What often happens is, or a practice which is done, is that the plants will be what's called topped, so they'll have that apical top cut off, which then promotes the sprout development on the lateral buds. A single plant can produce up to 100 sprouts, so they can be quite highly and densely packed onto the stem. Early cultivars tend to be shorter and produce fewer sprouts, whereas the taller cultivars produce more sprouts but are more prone to lodging, so they're more prone to falling over or being blown over in high winds. The sub-zero temperatures which the plants can tolerate and be grown in helps to improve the firmness of the buds, but also it also increases the sugars within the sprouts themselves and improves the flavour of them. So modern Brussels sprout cultivars are typically F1 hybrids nowadays. The plants tend to be incompatible, so this facilitates hybrid production and can be adapted by breeders to produce them. So the hybrids have improved uniformity and vigour, which is important for establishment in the field. They've also been bred for disease resistance traits and, as I said, improved flavour, as well as they're notorious for quite sulphury and bitter sensations. So Brussels sprouts grow well in a wide range of different organic and mineral soils. Optimal soil pH is between 6 and 6.5, but the plants can tolerate as low as 5.5 or as high as 6.8. The crops have a moderate requirement for nitrogen, and nitrogen deficiency can cause lower yields of sprouts and also delay maturity, and it has been associated with the production of off flavours in the buds. Nitrogen is typically applied at planting and again during the sprout formation, similar to broccoli and cauliflower. Excessive nitrogen can promote rapid growth, and the sprouts tend to become too large to sell if that happens. Like most Brassicales species, they have a high requirement for boron and molybdenum, and these deficiencies can cause chlorosis of the leaves, necrosis of the leaves, and even death of the whole plant if they're severe. So sprout formation is optimal between about 5 and 18 degrees. Temperatures above 25 degrees can cause the sprouts to become loose and develop strong flavours. So you can see in this slide here the sprouts at the top of the stem there are looking quite large and loose, so that might be because of exposure to high temperatures. Growth is generally slow at less than 5 degrees C, but it's well tolerated. And as I said, the leaves of the plants, which kind of hang down and cover the stem and protect the buds, offer a kind of insulating layer against very cold temperatures. And yet the cold temperatures themselves promotes a response in the plant to accumulate sugars, and therefore makes the buds taste more sweet. So this is just an example of a crop which has been grown in very cold, very severe winter conditions, and the plants are still harvestable under these types of conditions. And in fact, it is preferred that they're in some regions such as Idaho in the United States, where they can have very cold winters. Brussels sprout crops there are actually intentionally exposed to these kinds of conditions to improve their taste and flavour. So they can tolerate moderately severe winters, and which is and it's common winter crop in Europe and in the Americas as well, and particularly in northern United States and Canada. So maturation rates of Brussels sprout plants vary between 85 and 125 days after transplanting. Early cultivars mature much more quickly, so 85 to 90 days, and the later cultivars, they mature in about 110 to 125 days. And the sprouts, as I mentioned, are typically grown from transplants, as with other Brassicales varieties. The in-row spacing is about 25 to 60 centimeters between rows of about 50 to 90, so the plants do grow quite large and do need a bit of space in between. So the transplanting process shortens the time to maturation, and it improves the uniformity of development, and that again has been improved significantly with the use of F1 hybrids. The transplants themselves are usually ready for transplanting about 4 to 6 weeks after seeding. So Brussels sprouts require about 2.5 to 3.8 centimeters of water per week. Again, as with previous brassica crops we've talked about, they don't tolerate low soil moisture content very well, as this is detrimental to development and yields. Drought in the early stages of development will affect uniformity and development of the crop. And overhead irrigation isn't really encouraged because it promotes foliar disease, and so you can see in this crop a lot of the leaves there have some signs of fungal infections and starting to sort of turn yellow. So it's much more efficient to use drip irrigation or micro irrigation. So Brussels sprouts are kind of unusual in that unusual for Brassica oleracea varieties in that they can be quite easily harvested by a machine, but this is only really a recent development. Traditionally, stalks of Brussels sprouts would be harvested by hand, as with broccoli and cauliflower. So a machete would be used by a person to go along rows and cut the stems, and then the stems will be placed into crates, which would then be taken to factories for further processing and removal of the actual Brussels sprouts. But nowadays this process has been modernized, and special machines have been developed by Dutch engineers to harvest Brussels sprout stalks. So as you can see in this slide, the machine moves along the rows of the Brussels sprouts, and so humans sit on the front there. The machine has a cutter at the bottom, which is located under the occupant's seat. This severs the stem, they pick it up, and then they pass it into the machine, which then takes it through and removes the buds using beaters and vibration to knock them off the stem, and then they're deposited back into the rear of the machine here. So harvesting typically begins when sprouts are firm and about 2.5 to 5 centimeters in diameter. Sprouts are traditionally harvested by hand, as I said, but this is now being superseded by the introduction of machines. And yields can range anywhere from about 6 to 20 tonnes per hectare. And this is just kind of a close-up and of a machine which might be in the back of one of those rigs. So essentially the stalks are inserted bottom end first into the machine, and so then it will take the stalk through, knock off the Brussels sprouts, and discard the stems and tops. And this is quite common for frozen and processed markets, but it can be done gently enough so that the sprouts aren't damaged and they can be sold for the fresh market too. And this is just an image of a processing line in a Brussels sprout facility. So once they've come from the field, they'll typically be cooled down and have the field heat taken out of them and cooled to about 0 degrees C. Sprouts can be processed through a combination of graders, such as on this line here, but it can also involve humans on a grading line as well, picking out defective sprouts. Increasingly, the grading and packaging of sprouts is performed mechanically because it's more cost effective and quicker to do. And the sprouts themselves can be stored for up to 30 days under the correct conditions. So in summary, Brussels sprouts are a cold season crop that are very tolerant to cold and freezing temperatures. Plants are cultivated for their lateral buds, which develop along a single stem. Crops have moderate nutritional needs but can suffer from nitrogen, boron and molybdenum deficiencies. Crops are traditionally harvested by hand, but nowadays can be harvested more effectively through use of mechanization. And sprouts are processed by hand and machine and have a long shelf life if stored properly.